Hello, let's do coding! I started to write second stage bootloader for RP2040 and I call it YasBoot, just another simple bootloader. It will support not only RP2040 but also other cores. So let's go. I wasn't sure how to start, so I started by creating empty project. After that I added Pico SDK and tried with Hello World from their codebase. And as we can see, it was working. After that, I've created some project helpers like Clang format. Look how huge it is! It won't fit in 32 kilobytes. As a package manager, I'm using Yaspim. It's very simple package manager. And I decided to use keyconfig as a configurator for my project because I like this terminal-based menu config that they are providing. But keyconfig failed, and again and again and once more and again. So if you are my future employer, don't watch that, go on to the next one. Fun fact, did you know that first computer mouse was created by Douglas Engelbart and it was created from wood? When keyconfig starts to work, I created Python script that appends checksum to bootloader that will be placed at the beginning of Flash. And it's time for assembly language. It must be written in assembly language because it must follow specific layout, and after a while I started to debugging and of course nothing was working. Basically my code wasn't loaded because RP2040 was not able to verify my checksum. Oh, and there is a proof that I was using Bing AI. It fixed many of my bugs. And maybe just a reminder how the booting process looks like in RP2040. So firstly, the boot ROM is starting and it loads 256 bytes from SPI flash to RAM memory and executes it. And this tiny code should initialize hardware to be able to execute in place mode. And this is necessary because the flash memory that is connected to RP2040 is visible on the bus. So the memory layout in my project will be like that. Firstly, we have this second stage bootloader for Pico boot ROM. Just after that, there is padding to 212. And in that gap, I will add some additional code, for example, bootstrap code that will load the next section. And the next section goes just after that. I want to keep the first block as a master boot record, like in normal PC. And after that, my YasBoot bootloader will check partition table from MBR and selects the table image. And in the future, there will be possibilities to boot not only from internal flash memory, but maybe also from USB and maybe from SD card. And going further, I started to create my second stage bootloader. Because I want to fit YasBoot in partition scheme like MBR. So the first stage must fit in 212 bytes, and after that there will be actual bootloader implementation. And I even started to writing it. I started with creation of hardware abstraction layer, and this is necessary because I want to use different hardwares and maybe do some steps to be testable on host computer. So thanks to that, there will be abstraction between hardware physical layer and logical layers. Of course, something was not working, so I use Logic Analyzer and see what's going on. Basically, this code should print some bytes on serial port, but it didn't. And after hour of fight, I decided to flash example from Pico SDK, and then I realized that the GPIO with Pico SDK is in high mode. But in my case it wasn't. And the bug was trivial. I've missed line that was enabling GPIO. It's a demo time. I'm calling menu config, there is a configuration. For now you can select only one board, but in future there will be more options because I want to configure many things here.
1 hour later, 2 hours later, 3 hours later.
Can you move it along? I'm all out of time card.
2,000 years later.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Filing. Oh, it was fast. And look how small it is. I reduced size. Now it fits in 2 kilobytes. And that's why I'm not using here Pico SDK. It's faster to write, but harder to maintain memory layout that I won't keep. Thanks for watching and see you soon!